It asked it asked about, probability A is zero point 0.7, probability of B is 0.4.
Yeah.
I think generally these all made sense. Maybe we can talk about it later. But my question is, I understand the can A and B be independent, but I was wondering about this part. And if the C is referring to, does that mean it's asking about the complement?
Yeah, it's true.
Okay. So it is like, so I was thinking like, so P A, like I was thinking it was the same thing because, but I don't know if I'm getting it wrong, but I was like, are they asking for the complement? I wasn't 100% sure
Okay,
if that's
okay.
what the C meant. Yeah.
Okay, so first, like when talking about complement, probably we have two notations. First is like here, P A union B
Hmm.
parenthesis complement. And another way to write it is P A union B and a bar, a long bar above A union B.
Yep.
That
Hmm.
basically those two are the same thing, both about the complement. And here, when you draw the, like I call this a Venn diagram. When you
Yep.
draw this Venn diagram, you should um, have a, like you should have a limit, because understand all the probability should be between 0 and 1. So when I draw this kind of graph, I will draw like a huge rectangular, uh,
Oh, I see.
which
Yeah.
yeah,
I know
which
what you
is
mean.
which includes the probability of 1, which includes all the events possible. So
Hmm. I did not go all the way back into. Well, we can just do this at least.
yeah, that's perfect. And so the complement means not included in A union B, right? So first question, if I ask you what is A union B?
Uh, it is. Hold on. Let me go back up. Uh, isn't it the
Remember, A union B means A or B or A and B,
Yep.
right? So here, when you draw this graph, when you draw this two circle, one represents A and another represents B. A union B is just your circle and two circle and including the intersection part.
Hmm.
It's a very weird um, graph, like um, so it's just A union B is just a two circle, and
Hmm.
you don't double count the intersection part.
Yep. Hmm.
That's the union. So so the complement of A union B is just everything outside your two circle, but inside the
Uh,
rectangular.
oh, let's get rid of that.
Yeah.
So it would be um, like one minus A union B, which I
No,
had. I don't think that's right though. Now that I'm thinking about it, why did I do
you
that?
like for this particular question, you are not gonna use like your answer from above from part A, B, C, D, because here we assume independence. Independence means here you can calculate what is A intersect B.
Hmm.
Right? A intersect B is both A and B,
Yep.
and it's just the product of the probability of A and probability of B. Because remember, when we assume independence, that means the outcome of A will not influence the outcome of B.
Hmm.
Right? It's like tossing two coins.
Yep.
It doesn't matter if my first toes is a head or a tail. My
Hmm.
probability of the second toes is always 1/2. It's not
Yep.
influenced. So that is the independent event.
Yep.
And in that
Okay,
way,
so I was right about that.
yeah, in that way, like my probability of tossing two heads is simply 1/2 multiplied by 1/2. So
Yep.
as long as we have the independent assumption, we can just multiply two events to get the intersection.
Hmm.
So you know what is A intersect B, and how to calculate the A union B the A union BC. It's you have to use kind of some formula, uh,
Hmm.
just probability formula to playing around. Um, for example, um, you will find what is the probability of A union B, right? And if you remember, it applies to all the scenario, not limited to independent event. The probability of A union B equals probability of A plus the probability of B minus
Hmm.
the probability of A intersection B,
Hmm.
right? So
So I think that's what I did here. So that, because it would be 0.7 plus 0.4 minus 0.28, right? And I think that's 0.82.
um, no, it's not necessarily because when you're doing part A, B, C, and D, you don't have the independence assumption. So, for example,
Mm.
in part B, the maximum value here, the 0.28, you are calculating the 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 only value for A intersect B if they are independent. But here they are asking you what is the maximum value. So when you draw the Venn diagram, maybe you can use B as a pretty small circle. I mean, just in part B, right? Because it's just a 0.4. The probability is just 0.4, and you
Mm.
just draw the B inside the A, and you'll find that
Ah.
A intersect B is equal to 0.4 because that is just the region of B.
Hmm.
So here, when it comes to maximum and minimum, you don't assume independence.
Oh, geez. Okay.
And for part
I hate
A
this.
also, you can't say that the probability of A intersect B is 0.
Because we don't know it's independent.
Because what do you mean? Like when you're answering those kind of question, the best way is you draw a diagram. So
Hmm.
so when you say the probability of A intersect B is 0, you are saying like those two circles are not touching each other at all, right?
Hmm.
You draw a single circle of A and then you draw a circle of B and they are not touching each other at all. But what you find is here, and also you draw a big rectangular, but you
Hmm.
find that the probability of A plus B plus the probability of B is 1.1, which exceeds 1 already.
Yeah.
So that's nonsense. So you have to make A and B touching each other to make sure the whole area is less or equal to 1. So you have to draw a graph which is pretty similar to part E, but here the intersection is only 0.1, right? When the intersection is 0.1, the area of the whole graph would be 0.7 plus 0.4 minus 0.1 and equals to 1,
Yeah.
which means the rectangular is just that much large.
Yeah.
There's
Just
no larger rectangular.
it fits exactly. And
Yeah.
what? But that's not the minimum value. That would be the maximum value.
The as I said, the maximum value would be 0.4 because you draw a circle B exactly inside the circle A.
But then, but the minimum value is 0.1, as you're saying. You're not saying it's 1. You're saying the minimum value is 0.1 because that's the minimum intersection there.
Yeah, and the
Okay.
maximum intersection would be the whole area of B, which is
Okay.
0.4.
Which is just, Why is it not 0.7? I'm sorry, like we're going slow here.
So for part B, right?
Yeah. Why is it not 0.7 if that's like the larger of the two probabilities? Or it's
Um,
no, wait. So it's the intersection. Sorry. So it's an
yeah,
intersection. So
yeah,
the intersection is only 0.4 because it's within the broader 0.7. Okay.
yeah.
Actually, that makes sense. No.
And go back to your question. Point 7 is actually one of the answer of those questions, and you think about what is. So because for part B, it's intersection, right? But what if it's a union, like for part C?
The minimum value for A and B
Yeah,
of and that's the addition. There's no intersection, right? So it's
yeah, it's a union. It's not intersection. The graph is exactly the same as
with
part B.
and the so it would then be still within inside of it. So the minimum value for the probability of PAUB. So the union of both of them together is 0.7.
Yeah,
So it's not like
exactly,
it's asking what the bigger circle is.
exactly.
Man, I'm really glad we were talking about this. Jeez. What, um, and then so the maximum value then would be that they're separate again, but it can't be 1.1 because that's impossible within the box, right? So would it just be one?
Yeah, exactly.
Really glad we talked about this. Well, I was like, I think I got those ones. No, I didn't.
It's a tricky
Uh,
question. Like a more standardized question would be like, for example, probability of A equals zero point 0.3, probability of B equals zero point 0.4. So to make the sum of them less than one. But like here, the professor make it a little bit tricky because it exceeds one, and
yeah.
you have to playing around.
Okay. No, I'm glad we talked about the graph because I saw like I missed the point that this is supposed to like represent like the whole and like and that is one and how does it all fit within one? So
Yes.
that is very important. Um, thank you. The next question, I really was struggling with how to set this up because I felt like it was almost a like continuous like example if or if that makes sense like and I didn't want it didn't make sense it said at random between 0 and 1 and
Yep.
that means that it's less than 1 so but I didn't know how to make like the so I was like okay I know it's supposed to be like this of it's going to be the probability of winning is greater than 0.5 but less than 1 but I
Yep.
couldn't figure out then how to like I was like but I'm like using these like I was like I don't think it's right to be using because it could be any number of decimal points. So I was kind of like I don't know how to set it up further than this because I know it's not supposed to be this way, but I don't know how to accommodate for the less than 1 in setting it up. Does that make sense? You
Yeah.
know,
Yeah. So yeah, there exists a continuous model, but I will argue the most important model in this problem is still binomial model. The
uh,
continuous model helps you to find the probability um, of each number.
mhm.
But to answer this question, you need to apply um, binomial
The
model.
binomial equation. Okay.
Yeah. So first, it asks the player wins if at least one of the numbers he picks exists some value beta. So
Yep.
whenever you see those at least question, at least,
Mhm.
I suggest you think about the complements, which means
Oh,
because it's very tricky. Like for example, I pick
yes.
3 times, I pick 4 times. I mean at least one time. What does that mean? That means I can pick 1 time, I can pick 2 times, I can pick
Yep.
3 times or 4 times. You calculate those four probabilities and add them together, and sometimes it's not simply adding them together.
Yep.
You need to like for example minus the intersection part or something. It
Yep.
becomes very complicated. But what I can do is I just calculate the probability of not picking even once. So that is
Mm-hmm.
the complement. And it's way easier. And then I use 1 minus my complement. And I
Okay.
get my answer of at least one time. So whenever you see the at least, I would suggest thinking about complement. So
So then it would be like, eh. Well, I know it's like one minus the probability. So the probability of A to the C. Oh, equals one minus P of A, right?
yeah, it's always true.
Um, then would it then be is it 1 minus 0.5? But then like there's some squared element to that, just twice.
Yeah, that is a pretty good intuition. So basically, they asked me that beta equals 0.5, right? So
Yeah.
so like for the complement, my goal is I just pick something less than 0.5. And here exists a continuous probability model. What is the
Yep.
probability of picking something less than 0.5 when my
Yep.
interval is between 0 and 1? It's just 1/2. So,
Mhm.
and the two picks in a row. So that's to the power of 2. So that is correct, I think.
So quick,
Um,
let's get rid of this. Goodbye.
but here like that is I think. But the syllab is a little bit weird, like your formula syllab, because you ultimately you want to calculate the probability of A instead of the probability of A complement. So maybe you write as probability of A equals um, 1 minus probability of A complement.
Um, so then go away. So it's then 1 minus. So I kind of reverse the formula, is what you're saying.
Yeah.
Because it, okay. I'm just looking at what did I have in my notes? So I'm remembering what I'm supposed to do next time. Oh, it is odd. I did write it the other way last time.
Yeah.
So so I did get it wrong.
Yes.
So then it's point, then the complement though is still 0.5 squared. It's just a funky way that
Yes.
I just wrote it funky. Okay. Okay. I can do that math later. So then what is the value of B, which would make the game fair? I mean, you could do like the brute force method, right? Of just like,
Yeah, you can just solve that unknown because now you have the probability, which means the game fair means the probability is 50%,
yeah,
and it's just 1 minus the the 1 minus beta squared equals 50%, and now you want to solve for beta.
equals, I'll just do this now. 0.5 times 0.5 is 0.25. So it's 0.75 is up here. And then, so you're saying,
It's pretty much it's very similar to the like
but before,
question
so what is the value of B which make the game
the
fair? So
last home assignment. Yeah, you just so now I'm giving you
Yeah,
the
that's what I'm looking at.
probability.
I'm like,
I'm giving you the probability and ask you to solve for the beta.
so it's then like the 1 minus 0.5. Is it then almost to the, what is it, probability of beta? Is it like to the x?
No,
Versus-
here is not to the x. I'm not asking you to toast it more than 2 times. I mean, it's not
Mhm.
toast it, it's just picking 2 numbers. I'm still picking 2 times, right? But
Mhm.
what changes
Oh, it's still 2.
is
Okay.
that 0.5. What changes is that 0.5. Because remember in first question, why I said it's 0.5, because beta equals 0.5. And
Mhm.
the probability is just 1/2, because
Mhm.
choosing a number like below 0.5 in a scale of 0 to 1 is a continuous model. It's just 0.5 divided by 1. It's 50%. But
Yep.
now the beta is unknown. So that is a question. The beta is unknown. So basically I will say, because in first question, yeah, intuitively you have the probability is greater than 50%.
Mhm.
So in second question, I have to decrease my beta, right?
Mhm.
When I decrease my beta, the probability of complement not picking any number greater than beta, the probability of complement will decrease, right? For example, when beta equals 0.4, my probability would be 40%, right? So now what I'm going to do is I just assume the probability of complement maybe it equals p. So I would set up my formula like 1 minus p squared equals 50%.
Mhm. So
And
then you
I'm
do,
solving for p.
yep. So it's almost, so then it goes negative p squared, negative p squared. This is the fun part. Equals negative 0.5. And then you kind of take the square root of both.
Yeah.
So the
So first
square
you
root
can
of,
eliminate the minus notation.
yeah.
So it's
So
p
then
squared
p would
equals
be
0.5.
like be 0.25.
Now
No,
p should be something greater than 0.5.
I gotta go
Just
do
take the
this
square
somewhere.
root of 0.5. It's around 0.7, I guess. 0.71 something.
0.71. Let's try and see if I can find it. My calculator somewhere else. Oh, 0.5 equals, just kidding. Why are you not working? Maybe not. Okay, I'll solve that later. That it's
Yeah.
0.7 something. Well, I can do that.
Yeah.
It's easy. Okay.
So here
Wow,
like
I'm really glad we're talking because
so
I
for
was setting this
example,
up
if
all.
I just told you like 0.7 is what? 0.7 is a probability of complement,
Mhm.
right? So my what is my beta? Maybe my beta is not that number. Maybe yes. So you have to think through it, right? So if so now what I'm
So this, okay, so I see what you're saying. So we just solved P is equal to P complement. Is that?
yeah, so if you look back to the first problem, I told you if now I told you the probability is 0.7, right? If I said the player wins if at least one of numbers he picks exists the some value 0.7.
Mhm.
So So now, the first simple question, if that player only picks one time, what is the probability of winning when beta equals 0.7?
You only pick one time
Yeah,
and it's 0.7, you have a 70% chance of winning.
but you have to exceed 0.7 in a scale of 0 to 1. You pick a number greater than 0.7. It's a
So,
continuous model.
so you're saying if we no, I don't know what you're saying. What are you saying? It's
Yeah, I mean, so the rule is if I pick a number greater than 0.7, I win. And
oh,
I
but
can
you
only
can't
pick
choose
once.
exactly 0.7. It has to be something
It
more.
doesn't matter. It doesn't matter if I can choose if I can or cannot choose exactly 0.7.
But it would be why doesn't it matter?
Because the probability would equals to 1 minus 0.7 divided by 1.
Because it's
Right? Because
the n minus 2.
yeah, because I'm gonna pick a number greater than 0.7. So if we draw a line indicates 0 to 1, and I draw a point
Yeah, at
0.7.
0.7. Mm-hmm.
So exceed 0.7 means I only have 3/10 chance, right?
Oh, so okay. So it's that. Okay, would make
Right.
games fair.
So
Okay, I see what
that
you're
is a
saying. Yeah.
continuous
Yes.
model.
So it would have to. So the value is still 0.7. It's just that, but if you ask the next question of what is your chance of winning, it'd have to be over that number because you don't want, which means be between 0.7 and 1, which is then 30%. So you'd have a 30% chance of winning. Is that what?
Yeah.
Okay.
Yeah. So I'm picking
Oh,
one time, but if I'm picking two times,
then you'd have.
picking two times, I need to think about complement because my question is at least once, right? So you will use 1 minus 0.7 squared, 1 minus the
Yeah.
complement. So,
Okay.
but for
But and then
question
would it be
two,
the same for would it be the same for if you said you had to pick 4 times? It would be 1 minus 0.7 to the fourth.
yes. So
Yeah.
here you're
Okay.
using a binomial model, and
Okay.
why I say like if I pick 0.7, it doesn't
Hmm.
matter if that counts because
Hmm.
the probability of picking exactly 0.7, that very number, is 0. There's
Hmm.
no chance I can pick that number. It's just you want to find a point, a single point in a straight line. The
Yeah. Within.
probability is
Yeah.
just 0, so it
Yep.
doesn't matter. Okay?
Okay.
Yeah.
Yep. No, that makes sense. Huh. Wow. I really didn't get this at all. Uh, okay. So I'll be respectful of your time. And since you're here, though, we might as well do this one since I thought I did this right, but then was probably mistaken. Um, so this is the. I need to pull up my. I did this one using the like e to the negative lambda k over k factorial. Is that the right formula for this? And then plugged in according to the numbers. So like for this one, it was like so if they're paying like so if the equipment fails before the end of the first month, it was like 0.5, which was this. So e to the negative lambda. So I plugged in that times 0.69 divided by 1, because that was the factorial. So, and it was 0.69 to the 1, but that's obviously 1. This would usually be, and it was already, no, that's fine. Does that make sense? Like it should be the like, I don't even know how to show it to you.
You're like using a Poisson distribution.
Yes, yes.
Okay. So first, so here you're gonna use an exponential model. The Poisson model is basically used for calculating some small probability, like winning lotteries, something. So when my probability is very, very small, um, for example, I have like 1/1,000 chance to win a lottery. So what is the probability of winning like 2 lotteries out of 500 lottery purchase, something? Those things you're gonna use the Poisson models, but here it's just a very very simple exponential model. So
Rats.
the probability of a zero payment means I mean means this equipment
It fails in the first one. Yeah.
yeah, the equipment fails in the first month. So if you look at that formula, the P from T to unlimited equals to it's e to the power of minus 0.69 t. So
Is it
here
just calculating? Is it
what you
just putting
have,
1 month in?
yeah, but here you still you're gonna think about the complement because the unlimited means, so I would do like P from 1 to unlimited. That means my equipment fails after the first month, right? So P1 to unlimited is E to the negative 0.69 times 1, which is 0.5, the approximate value.
Yeah.
That
But you,
means there's 50% chance that my equipment fails after
yep.
the first month. So what is the probability of my equipment fails in the first month? 1 minus the complement.
So for this one, it's 0.5 times 1 equals 0.5. But then for you would do the complement, which is 1 minus 0.5, which is still 0.5. Is that what you mean?
Yeah, what you get for 0.5 is you through that you read the prompt where t is measured in month, use the approximate value e to the negative 0.69 equals 5. So I'm just plugging in t equals 1, right?
Yeah. So it'd be e to the negative 0.69 is 0.5. We already know that times
Yeah.
1 is 1 month.
But you should
And then
understand why I plug in t equals 1. It's just p from 1 to unlimited. So that is the probability of this equipment failing from the end of the first month to it never fails, right? And for the sake
and
of
why are you doing the complement for this one again? Just
because I'm computing the probability of it fails before the end of first month. You'll find
so
that
this I calculated with the this I'm calculating the probability of it not failing.
No, it calculates the probability of failing, but after the first month, because this equipment will ultimately fail.
After, okay.
The probability of equipment failing is one. It's just one, because if you just plug in, the equipment will ultimately fail, right? But you calculate the probability of it fails after the first month, which is 0.5. So the probability of it fails before the first month is just 1 minus 0.5. They have it's also a complement relationship.
Man, you would think
And so for the second question, you still use this kind of method, like between 10,000 and 20,000. 10,000 is like, I mean, so from if it fills between the first month and the second month, you get a compensation of 10,000. If it fills, like, I don't know the exact number, but you still use those kind of thoughts.
so it would then be whatever point that this is 0.25. But then you would still say, okay, this is the chance it fails after that.
So basically, you are calculating the probability of the equipment fails during the second month, third month, and fourth month.
But then, so it's equals 0.5 times 3 equals something 0.1. 0.125. 0.125. That doesn't feel.
No, it's not 0.5 times 2.
It's
It's probably 0.5 to the second power, I would say, but you should do it like you should use a calculator to compute that. It's just e to the power of minus 0.69 times 2. The times 2 is inside, it's on the upper hand. It's like 0.69 times 2. It's not the whole number times 2, right?
like, you mean like that, or do you mean it's not a subscript? Do you think it's this, like 0.69 times 2?
Yeah, it's 0.69 times 2, and the whole bunch of thing is the factorial on the e. It's e to the power of this thing. It's not e minus 0.69t. It's e to the power of minus 0.69t.
Oh, maybe I copied it. So you're saying, sorry, I probably just copied and pasted this in incorrectly, which is, so it's that.
Yeah.
Okay. And same thing here, just to.
Yes.
Oh, so I copied it. Well, that would change things, doesn't it? Yeah, this one is the reason that worked the way it did was because it's one.
Yeah.
Okay. Okay. So this. Let's just. But then would I just substitute for? So it's like this. It's like this. And then I can put E into the calculator. It doesn't have to, like, it's a constant, right?
Yeah. You can just put it
Like,
in the calculator.
Yeah.
But again, when you use complement, you
it would be
never
1
forget,
minus whatever I get here, whatever that result is. But then, actually, so then, I guess actually my question is, so I'm looking for month 2. So I feel like I'd want to find, like, the answer to each of these first, because I feel like I want to subtract this one to get the answer to 2.
Yeah.
Like, I don't, because it's, otherwise it's talking about everything, not like this one is. Okay. So it'd be.
So I'm gonna like use one formula to calculate this. right? So if you just translate what is between 10,000 to 30,000, I guess that is equals to it fills between the first month to fourth month, I guess. So
Hmm.
so it
It's,
starts from t equals 1
yep,
and ends from t equals 3 or 4. You should look at the question.
yeah,
Um,
yeah. So that's the fourth month. Yeah. So it's the second month is 10,000, and then the fourth month is 30,000, which is why there's the 2 and the 4. So is it then? It's so maybe we don't even need to calculate this one.
so what you're doing is you calculate p um, from what to what, the probability from what to what.
From month 2 to month 4. What do you mean?
Yeah, you're on the right track, but not from month 1, month 2 to month 4. You're on the right track again. Because when you say P from 2 to 4, it means T is
Oh, is it
greater than
like
2. So it's a start of the third month already. So what is the correct number you put in the parenthesis, the probability?
so? It's this one. It's the third month. Oh Jesus! I never would have gotten this.
Yeah,
Like
so you're gonna calculate the probability of
the
1
third and
to
is it?
3 from 1 to 3, right? So
Oh, because it's
you
not.
have the
Oh
formula.
God.
So now what you're gonna do is you need to utilize that formula as much as possible. The what exists on the very top of your screen. So, but that formula is the probability of from t to unlimited. But what you're gonna find now is a probability from 1 to 3, right?
Hmm.
So what you're doing is you just use the probability of 1 to unlimited minus the probability of 3 to unlimited, and you get the probability of 1 to 3.
Ugh. Hmm. This is rough. So the but why are you saying unlimited? That's what I'm. So
So
this is not for. So just to like. So if we were calculating, so I understand why you're saying month 1 to month 3, because we were trying to find in between those.
yeah,
Um, and you're saying if I do this right here, if I calculate each of these, the e to the negative whatever times 2 times 3, that's not the answer. It's not the sum of these three.
I guess it is. You can try this way. I guess it is. But how do you calculate, for example, the second one, n equals 2?
Uh, I
By the
have
way,
to.
it means the third month. N equals 2 means the third month.
Uh, so why isn't this one's 0 then?
Which one?
Well, so this one, I'm actually not. So this is the first month. The first that makes sense. That is the first month where there's a 0 payment from 0 to 30 or 31 days. First month there's a 0 payment. Then the second month is uh, is then $10,000
Yeah.
if the fail occurs. That makes sense. So I don't understand why I don't think we'd include this. I think it would be, we'd start it, because it's between 10,000 and 30.
So
So I
what
still
is
think I still think it's, um, uh, I think it's it should be T to 2 to the 4. I am not understanding why you're saying it's 1. It
okay
should be second, third,
to
fourth.
make it like more clear? I wouldn't say PT equals 2 or T equals 3. I would say the second one, I would write as P 2 and 3. 2, 2, 3. I just want to write as the formula, right?
Like this?
Yeah, and yeah, you can use this. I'm gonna use a comma between 2 comma 3. It's yeah, if you just look at the setup of the formula on the prompt, what does that say? It's a
Okay.
t comma unlimited.
So we
Yeah.
want to say it's T and it's 2 and 3.
Okay.
But I think it's
Yeah.
2, 3, and 4
So you just write 2 comma 4 because it's a period
because
of
it's 2
time,
to,
right?
okay. Yeah. Okay.
This
So
is
then,
what you wanna get.
so
Yeah.
then it is this plus, it's adding, but then it is adding these 3 up.
There is an easier way, and I would use that easier way later. But here, what I'm gonna try to explain is um, so for the first question, if you can write the setup like this, for the first one,
Uh-huh.
what is the P? P from which to which?
0 to 1.
Yeah, you get the point. So
Yeah.
so the second question is not P from 2 to 4, right?
Uh-huh.
You know the first one is from 0 to 1 because it's
Oh, so
before
it
the first
is,
month.
okay. So then it is starts at 1 and goes to 3. Man, I never would have figured that out. Like, uh, ay, ay, ay. So it's 1 to 3, so that's why it's that, and that's why you're saying that.
Yeah.
Man, that, yeah, zero chance I would ever get that. I know why you're saying it now, but like, I really hope there's no question on the exam with that because zero chance I would get it. Oh man. Okay, so then that's why you're saying it's, so then it is the, oops, the
And
one.
again, like here you're not gonna use 3, but you'll use 4. P from 1 to 4. Think about why that is the case.
Oh, geez, yeah. Okay. So it does include it because it's ending then. It's not, it's the end of month 4 because it goes 30,000 in the fourth month. So you have to go to the end of the fourth period.
So the end of the fourth month is equal to the start of the fifth month. So you're gonna use the 4.
Yep.
So that's from 1 to 4. That includes the beginning of the second month all the way to the end of the fourth month.
Yep. So then we calculate this and this is the answer. Ay, ay, ay.
So you're gonna use the formula. I would say you utilize that formula as much as possible. So from 1 to 4, you just use the probability of 1 to unlimited minus the probability of 4 to unlimited. And you just get an interval between. And what you're
Oh, so
gonna do
you're
is you
saying,
just
so you
plug
would
in
say,
numbers.
you'd say, forget this.
Yeah. What you're gonna do is you just plug in numbers. So so first you're gonna use just the probability of 1 to 4 is the probability of 1 to unlimited minus the probability of 4 to unlimited. And just get the interval between from 1 to 4.
But we don't know what T is here. What do you mean? So it's, so I would say, like, how would I calculate? I don't know what you mean.
Okay, so I just let you write it first and then
So it would be
understand.
this, it'd be the P that I understand why you're saying it'd
So you
be,
don't so first you don't plug in any number because it I mean it undermines you from thinking what is the essential of the problem. I would say first you just write the probability from 1 to unlimited minus the probability of 4 to unlimited.
So you mean like that?
Yeah, what is that? From 1 to unlimited means the probability of the equipment fails after first month.
Mm,
And the probability of 4 to unlimited means the probability of the equipment fail after the fourth month. And I minus that and I subtract this two. That means the probability of fails from the first month to the fourth month. That's something we want to
yeah.
calculate.
So yeah, it's that bracket of time. Yep. That makes sense.
And it's very easy to use this formula because you can just plug in the number to the 0.69t something. It's just e to the power of negative 0.69 times 1 minus,
Yeah, minus the
yeah, you can,
e to the
you can do that.
e to the times 4.
Yeah,
And then it's okay. So this would probably get me the same thing, but you're saying thinking that within the brackets of and the equation, this
yeah,
is how you kind of think through. Okay. Okay.
because what if I ask you the probability of failing between the first month to the 100 month? You're not gonna like calculate the probability of
It'll
failure
take
of
me,
each month. You
yeah,
just
it'll
use
take
that
me a
interval.
day. Yeah, you use it. Okay.
Yeah. And again,
Okay.
so I'm not quite sure it's a probability from 1 to 4 or 1 to 3 or 2
Yep.
to 3, 2 to 4. You should think through it. The calculation is pretty easy. You just plug a number, but you're gonna play around with the month because like at the start of first month, the end of first month, the start of second month, something.
Hmm.
You should understand how much month there is.
Hmm.
Okay. So
Yeah, like not just
yeah,
it's not as straightforward. You have to do the end of the first. Yeah.
yeah,
Okay. I need to go. What is this?
yeah. By the way, that is also kind of random variable. You every time you do a statistics problem, you're gonna transfer natural language to a set of random variables, right? So in the prompt, I say at the end of first month, at the beginning of first month, something. But here you just use 1 or 2 or something to interpret it,
Yeah.
and it's a pretty tough and a very valuable skill because you have to understand the natural language very well, and
Yeah.
then you can transfer that to numbers. Yeah.
Yeah. Okay. Um, hmm, okay. That's tricky. Very tricky. I'm very glad I've talked to you today because God knows this would have been bad.
Sure.
But but I'm also a little disheartened because I don't think I can do this on my own. But we're making progress. All right.
Yeah.
Um, thank you for your time.
Sure.
Um, is this a part of the homework? Does this count?
Yeah,
It's
I
kind
don't know if you're gonna try it. Um,
what does it mean if I don't try it? Will I still get 100 on the
you get
homework?
100 out of 100, but if you try it, you may get 125 something.
125. Well, I'm still not confident. There's no way I'll get it right. So,
But a hint to it is like whenever you try to calculate the expected value, the expected payment, something,
yeah.
you use the payment multiplied by the probability. That is the expected
Yeah.
payment, right?
Yeah.
So here you're gonna use the payment. So first, the payment is an unlimited series from 10,000 to 20,000, 30,000, unlimited
Yeah.
series.
40. Yeah. Mhm.
And then the probability is what you're gonna calculate like you do, because you need to calculate the probability of each part of each month, because
Mhm.
every month is different. And
Yep.
you're gonna use that probability times the compensation value. And that is a series. It's not even a geometric series because
to
Like,
continue. Well, it's never ending, right?
yeah,
So
the values are increasing every time from 10,000, 20,000 to 30,000.
yep,
And the probability is changing every time. Maybe the probability changing is a geometric theory, but yeah,
yeah,
but
but
the
it's
number
continuous.
multiplied is is another theory. So
Mhm.
you need to do some, I think it's some complicated algebra manipulation.
Oh boy, the last time I did algebra was 15 years ago. All right. Um, okay. I'm probably not going to attempt it because it'll just dishearten me. And I feel like I at least learned something and I'm in a better place by far than I was an hour
Yeah,
ago. So thank you. And well, yeah, we're starting with the basics here.
yeah,
But thank you, Victor. I appreciate your time.
sure,
Honestly,
sure,
I
no
know it's your
problem,
Sunday morning. I hope you
no
get to
problem.
enjoy your day. Go hike or something tomorrow.
Yeah,
I'm sure I'll be here next week. See you later.
sure, sure. See you.
Bye.
Have a great weekend.
Bye.
Bye.